Hello, welcome to uh, this my YouTube channel. Today we are going to do regression analysis with Python, and then um, the last video I made is on machine learning, and there is some kind of difference between machine learning and then statistical modeling in terms of their focus and all that. So with machine learning, we mainly do predictive modeling. We want to build a model that will be able to do well on a data it has not seen. But when it comes to statistical modeling, it is more mathematical based, and then we like to, or we normally explore the relationship between various variables. We want to know um, the relationship between one variable on the other. So we want to mainly look at the present or the past. We want to know what is happening and try to at least study the relationship between or among various variables. All right, so I'm going to use some real estate data today, and I'm going to do some analysis. So let's start importing our libraries. So I like to import pandas as PD, and I'm going to import let me import seaborn, and I'm going to also import from Statsmodels. I'm going to import Statsmodels of API as what SM. That is what I'm going to use for my regression analysis. Import Statsmodels API as my SM, right? I'll just execute this one. If I need any library, I'll come and add that library over there. Then we'll use that library to explore. All right, then let's run that. All right, it's running. My machine is a bit low, but it's still running. Um, it will be done very soon. I'm importing all these libraries all at once, so it's still doing, and it will be done shortly. Okay, all right, it's done. So I'm going to import my data. So let me just say data is equals to what PD, which is my pandas, dot read underscore what. I'm going to use this to help me. It's an Excel data, so I want to get in Excel. All right, this is the data I want to use. I'm just copying my path, so I'll just put in that. I'll just add that as well. All right, so I'll just execute this, and it's done. So let me ask Python to give me the head. Let me display some data, just the head. This is my data, right? I have districts, I have location, I have selling price, I have dates, I have living area, I have supplementary area, I have the build year, I have the tax value, the plot area, the standard, the tax year, and the prime rate, right? So I'm going to do or make a simple regression analysis over here with my selling price as a dependent variable, and I want to include living area. I want to include what the build year, and I want to include the plot area. All right, I want to include the plot. I want to study, make a like a regression analysis of these three variables on a selling price. What would that happen to this? What will happen? What is their relationship with the selling price over here? All right. So if you want to do your statistics or your summary statistics, you can just go ahead and do that. So I have data here, and I'm going to do summary statistics. I'm not going to do it for all variables. I'll just select the ones I want. So I'll just copy this, paste. All right, the variables I'm going to use for my analysis, I'm just going to add them and just do a summary statistics for all of them. All right. What am I adding? Adding the build here, and then I'm going to add the plot area. All right, let me take the tax value. I'm just going to ask Python to describe it for me. But now I have a problem somewhere. All right, it's done over here. So we have this, and then you have the count, and you have seen over here that the count is different, right? The number of observations here is different. You have 322, 406, and 408, and then 41. That's to tell you that we have what missing data over here. That means we have what missing data over here. But that shouldn't be a problem. Let me just see. Let me check the number of missing data we have. So let me just check data dot is na. Let me just add some. All right. And what are we seeing? We are seeing that we have what missing data or missing values here. And what that tells us is that the selling price, or when you look at this one over here, 92% or 92 observation is not inside. We don't have 92. We have 92 missing values when you take the selling price. And then when you look at we added what again? The living area. Living area, we have eight missing values. And then when you look at what supplementary area, about 11 missing values. The build here, we have about 6 missing values. The tax value, we have about 3 missing values, and in that order. But with the district and location, and then the tax here, the prime rate, we have 0 missing value. In other words, all the data is what is intact. We do not have what missing values. All right. So we are just going to go ahead and build our data, build our thing to see. But before we do that, maybe let me just drop. But if I drop 92, it's not gonna be. If I drop 92, it's not gonna. Alright, we have what 414. That should be the normal observations that we have. We have what 414. If you take 414, if you take 92 out of 414, take this out of it. No. So let me just leave it and let's go ahead and see if we can build a model. If we cannot build a model, then we'll come back and drop our missing values. But this is data. So now I'm going to what separate my data into two. One for what, my x's, and one for my what for my y's. All right, one for my x's and one for my y. One which is going to be my dependent variable, and one which is going to be my independent variable. Because a dependent variable is gonna be selling price. So let me just put that as y. That actually worked. And let me also add my x. We are including what the living area. I'll just copy them and paste. That's what I'm trying to do. I'll just copy the ones I need and paste. All right, that is done. So we are now going to fit our model. So let me just say my model is equals to what SM. I'm going to do what an OLS model. That is a linear regression model. Same OLS. So I'll just do model SM dot. And I'll use my tab to get OLS, right? So when you scroll through, you have all these over here. But I need OLS, so I'll just click on OLS, and I'll bring my Y, and then my X, right? I'm going to what fit my model. This is the problem. The unions contain info. Alright. The unions contain what? Ints or what nouns. That means you have what? That is the mission values that I'm talking about over here. So I think we can just go ahead and drop our missing values. I'm going to drop our missing values. So I'm going to do data dot drop. I'm going to drop NA, right? And I'm going to do in place equals true. Alright, that is done. And so when I come and check the length again, see that we now have 308 observations. That means that we have dropped about we had got 4, we had 4. When we're doing we had what? We had 14, right? We had 4. We had 4. So we had 414. We had 414 minus 30. So 414 minus 30. So 414 minus 30. And what are you going to get? You're going to get something nice, right? You have 414 minus 30. And you're going to have, what if you take 414 minus 30, you will know the number of values that you dropped away. I don't know what is happening. So we can then come back here and execute this again. And I'm now going to come back here and I'm going to fit my values again. Right, so I now have it. Now that I have it, I'm now going to print it out. Right. I'm now going to print out my model. I'm just going to do model dot summary. I'm going to print that out. Now, so you see that while I will be able to estimate our values over here, right? So we see that we have what? We have our R squared here, which is very big, 0.965, very high, right? And then we have what? Our adjusted R squared is what? 0.965, almost the same. And what have we seen? We've seen that what? The build here is what? Is significant, highly significant, and the tax value is highly significant. You can see from the p values, but we can see that what the living area is not that significant. But you've seen that what when you look at the model, you can see that we don't have the constant inside. When you build this model like this, the constant is not added, right? So that means that we have to add our constant. We have to add our constant. So to add that constant, I'll just come here and create another variable that is x var, and it's equals. I'm going to do x sm dot. I'm going to do add underscore constant. And I'm going to add it to what my x. That is what the independent variable. I'm going to add a constant to that one because we will want the constant to appear here, to appear just below this area, above or below it, where we can do our prediction very well. So I'm going to execute this one again. I'm going to change this one to x var, right? Because this is now a new variable that we want to fit. So I'll do that. And I'm going to print the model again. And fine, we've seen that what our constant is back, our constant is in, and our constant is significant. We've seen that what the build here is significant. We've seen that the tax value too is significant, right? They're all significant. But we've seen that what the living area is not significant. So this is our. But we've seen that what the constant. If the constant is brought inside, we can see that what our R squared has dropped, right, to 0.812. Our R squared has dropped to 0.812. Maybe it makes more sense to leave our constant out, because bringing the constant in wouldn't really add anything, because you can't say you will sell the building, or you rent out the building if you do not have living area, if you do not have a build here, or if you don't have the tax value. I don't think you'll be able to do that, right? But we've seen that. Let's just try to interpret this. What we've seen is our if 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 we have a unit increase in our living area, where we are seeing that what, how do you call it, the selling price of the building will drop by what, 0.7989, right? And the building year, right? You know what, a year increase in the building year, or maybe somebody who built this out just recently, maybe the selling price is likely to drop by this value. The selling price is likely to drop by this value. That is 3.7174. And the tax value, right? If you know what, if the tax value increases by 1 unit, then we think that what the selling price of that building will increase by what, 1.5079. And we've seen that below here we have what, we have the Boston test, we have our Jagbera test, we have our probabilities. That is the Jagbera probabilities. We have our skewness here, ketosis here, and then we have our, and here itself we have what, the dependent variable here, which is the selling price. The model we are saying the model is an OLS model. The method is just least squares, right? We have our SF statistics here, which is over here. We have the probability, which is also here. We have the log likelihood value, which is here. We have the AIC and the BIC, which is the archaic criteria here. And then we have what, the difference between our residuals and the difference in our models here. And then we have all this over here. And we have the covariance type, which is non-bust, right? So we've seen that what we'll be able to do a simple regression analysis over here, and that is how you do what, regression analysis with Python, right? And when you go to Stata, when you compare this value with any other thing, or with any other software, you see that you're going to get the same R squared. We're going to get the same values, and there will not be any difference. There won't be any difference. Right? Thank you guys very much, and please subscribe to my YouTube channel. If you have not subscribed, please hit the subscribe button. And if you have any problem, please drop it in the comment section. This is how you build a linear model. So before you can even build, you know that what you have to drop machine value. You have to handle what, machine values. You have to handle them. You have to even, before you can even build, you have to even handle what, how do you call it, outliers, right? We didn't even look at outliers, but you can look at outliers over here if you want to. With the selling price, you could have look at SNS. That's why we imported it, and I'm gonna bring a box plot. Inside the box plot, what do I want? My data. I'm gonna make a box plot for what, for my selling price. I just copy the selling price here. Right, and data is equals to data. So we have a problem here. Let me hit this one again. All right, I'll hit this one again because we have a problem here. So you see that we have our box plot over here. This is the minimum value. This is the maximum value. This is the median. This is the median, right? This is the lower quartile. This is the upper quartile, right? And these values over here, they are all what, outliers. They are all outliers. So before you even go ahead, maybe you can try dropping we can probably try to drop these values over here, and a good way you can probably get to these values is using the plotly.express package. So I can do plotly.express as what px. I'm going to import that, so I can import that library. It's gonna help me, and I'm going to do px.boxplot. px.boxplot. I'm coming. All right. So I'm supposed to put the data first. So you can see that what the value, the selling price 6,700 above is an outlier. So before we can go ahead and build a model, you can just come here and see that the selling price, which is 6,700 and above, is an outlier. So it is good to drop take selling price and drop the value 7,700 and any value above before you can then use that value to plot. And that will help us to make a general statement or to generalize our model, or that will help us achieve normality. And when you achieve normality, you can use that model to make a generalized statement or to make an informed statement that will cover people you have not been able to what, or areas you haven't been able to what, to go take data from. You can use just this data, and you're able to make a general statement which will actually start. Yes. So please subscribe to my YouTube channel, and thanks very much.